Hello everyone. Today we'll be working on section 7.2, inductive reasoning to find the nth term. So for 7.1, we were able to find a specific term, and for 7.2, we'll be able to find the nth term, so a general term. Okay? So what we're doing here is we're determining a relationship between the figure number and the value of that figure. So, first example here, we have three figures, and the question asks you to determine the number of triangles in the nth term. Okay, so what I'm gonna do first is I'm gonna make a table, as I think it's the easiest way to analyze the problem. So on the left column, I'll say figure number, and on the right column, I'll write down number of triangles. So for the first figure, how many triangles do I have? I have one. And for the second figure, I have 1, 2, 3, 4 triangles. And for the third figure, I have 4 plus 5, so 9 triangles. And if you were to add one more figure 4, then how many triangles would you have? You have 9 plus 1, 2, 3, 4, 5, 6, 7. 9 plus 7, that will be 16. If you have the fourth figure, it would be 16 of them. So now the question is, how many triangles would you have for the nth figure? So just by analyzing the table, what do you guys notice? Well, 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, and 1 is 1 squared. What do you guys notice? These numbers on the right column are all perfect squares, and the base of these perfect squares are the figure number, right? So for the first figure, the number of triangles is 1 squared, and then 2 squared, etc. So for my nth figure, then the answer is, of course, going to be the figure number n squared. Okay, so the number of triangles is equal to n squared for the nth figure, or for the nth term. Okay, let's try another example. So the second example here, we have a list of numbers. And again, I'm going to make a table of values just to analyze my question. And this time we're going to do term number and then the value. So for my first term, the value of my first term is 3. Second term is equal to 7, and then we have third term, that's 11. Fourth term, 15, and we want to find the nth term. Okay, so let's take a look at the values and how it's changing. Okay, so we can see that for the first term, well, it's 3, and then second term, 7 is equal to 3 plus 4. Okay, and then 11 is equal to 3 plus, 7 plus 4, and 15 is equal to 11 plus 4. So each of the term is equal to the previous term plus 4. Okay, and if we rewrite these, 7 plus 4 is the same as saying 3 plus 4 plus 4. And then 11 is that plus 4. So 3 plus 4 plus 4, and then plus 4. So if we were to write an equation for each of these, what is that going to be? Well, the first one, 7 is 3 plus 4 times 1 because there's only one 4. And then 11 is equal to 3 plus 4 times 2 because there are two 4s. And then 15, 3 plus 4 times 3. And then the first one, 3, it's 3 plus 0 fours. Okay, so what do you guys notice? Well, the first term is always 3, and then the second term is always 4 times by a number. And what are these numbers come from? Where are they come from? Well, let's take a look. When we have the first term, the number we're multiplying is 0. For the second term, the number we're multiplying is 1, and then third term, 2, fourth term, 3. Well, so we can say that the number we're multiplying here is always 1 less than the term number. Okay, so let's write down an equation for the nth term. Okay, remember the number where it's equal to the first term is always 3, and then plus 4 times by something we don't know, 4 times by a number. And this number is always 1 less than the term number. And the term number is n. If we have 1 less than n, it's n minus 1. Okay? All right. Let's move on to the next page. Okay. So next, we're going to go over the counterexamples. So a counterexample is an example that is inconsistent with a general statement and may be used in argument against it. So counterexamples will prove the statement false. Okay, so here's an example. Find a counterexample if the statement is false. Okay, so the first statement here says every prime number is odd. Well, is it true or false? Of course, it's false. Now, if you are saying that a statement is false, then you need to provide a counterexample to prove that it's false. And the only counterexample for this question will be 2. 2 is a prime number. And is an even number as well. Okay. So we found that 2 is a prime number and it's not odd. And so 2 will be a counterexample. Okay. Next one, for any real number x, x squared is greater than x. Is it true or false? Again, this one is false as well, because let's find a few counterexamples for this one. For example, 0 will be a counterexample because 0 squared is equal to 0. It's not greater than 0. It's not greater than 0. 1 could be another one. 1 squared is equal to 1. Not greater than itself. And then we can also have something like 0.5. 0.5 is a real number. It satisfies the condition, right? But 0.5 squared is equal to 0.25. Is 0.25 greater than 0.5? No, of course not. 0.25 is less than 0.5. So these are the counterexamples that can be used to prove that this statement is false. Okay, so that's it for today's lesson. Please try these homework questions in your workbook. Let me know if you have any questions.